If I have a velocity time graph, I can use it to find displacement. You will remember maybe that displacement is a change in position. It is final position minus initial position. So this is just a position time graph to remind you that displacement would just be how far an object traveled and in what direction. From start to end or between any 2 points that I denote, I can use a position time graph to find out how far an object moved in which way. So here we can see the object started at a position of positive 10. 5 seconds later, which for displacement we really don't care about time, but 5 seconds later it ended up at the reference point. So what was its displacement? Its displacement was negative 10. Displacement is a vector, so it does have direction. So it is significant that this moved 10 meters in a negative direction. And so if I know that, if I can find that displacement, if I know average velocity, I can also find displacement. So if I have a velocity time graph, I can find displacement, because what are the only things? This is our definition of average velocity, delta x over delta t. If I know average velocity, which I do, if I have a velocity time graph and I know delta t, which I do, if I have a velocity time graph, I can multiply them. I can get displacement. Let's go through some examples. Here's a position time graph again. We see the average velocity, right? It went down 10 in 5 seconds, minus 10 over 5. I'm just finding the slope. I have these 2 points, so make sure you can do that. You should be able to do that. Is negative 2 meters per second. I go ahead and I make my velocity time graph, and it's showing that for 5 seconds, this object traveled at a constant velocity of negative 2 meters per second. So if I ask you, if I say, hey, if an object travels at 2 meters per second for 5 seconds, how far does it go? You could probably do that in your head. So what calculation would you be doing? You would be doing this calculation. You'd be saying, well, I know average velocity is displacement over time. And I know, therefore, that displacement is average velocity multiplied by time. So I just put in that average velocity, which was negative 2. The time that it traveled at that velocity, that was 5 seconds. Negative 2 times 5 is negative 10 meters. We get the exact same answer we would get from the position time graph, which is good because we should. Here's another example. Find the displacement. Well, we have this object traveling at 4 meters per second in a negative direction. So what does that mean? It means we make some direction negative. Maybe it's left, maybe it's right, whatever. It's going in a negative direction. That negative is just saying it's going in a particular direction that we decided was negative. It goes 4 meters per second for 5 seconds, and then for 6 more seconds, from 5 to 11 seconds, this object goes at a constant velocity of negative 2 meters per second. It slows down to half its original speed. And you want to know, well, if this is going on, how far does it go? So we're going to do 2 calculations here. We see that in those first 5 seconds, that's that calculation on the left, I start with my original equation. Average velocity is displacement over time. Displacement is average velocity times time. This is just algebra. This is just solving for displacement. It went negative 4 meters per second for 5 seconds. So in that first interval, those first 5 seconds, its displacement was negative 20 meters. Negative 20 meters from where? I don't know. It's a velocity time graph. I have no idea where it started. I just know that from the time this event began at 0 seconds to 5 seconds in, it went 20 meters in the negative direction. Then what did it do? Then it went another 12 meters in the negative direction. And so its total displacement, I would add those up. Negative 20 plus negative 12 is negative 32. Its displacement would be negative 32 meters. Here's another one. For 5 seconds, this thing traveled at a constant velocity of negative 2 meters per second, and then for 5 more seconds, it traveled at a constant velocity of positive 2 meters per second. Hopefully, you can see where this one's going, right? So it starts somewhere. Let's say it starts at 0, even though in a velocity time graph, I have no idea where it starts. Let's say it starts at 0. It goes 2 meters per second in the negative direction for 5 seconds, then 2 meters per second in a positive direction for 5 seconds. Where does it end up? Well, it ends up back at 0, and here's the math to prove it. Well, I guess it's not the math to prove it. You can do the math to prove it. Delta x is v bar t, so it's negative 2 times 5, which is negative 10. For the next 5 seconds, between 5 seconds and 10 seconds, it's positive 2 times 5 seconds. Remember, just because it ends on 10 doesn't mean it was going at 2 meters per second for 10 seconds. It was just for those 5 seconds. And that's positive 10. And if I have positive 10 and negative 10, I add them together to find my total displacement, and it is 0. This thing ends up right back where it started. Well, this looks like a pain in the neck, but we can see here that for 2 seconds it goes at negative 2 meters per second. So that negative just means it's going in a negative direction at 2 meters per second for 2 seconds. From 2 to 7 seconds, that's 5 seconds, it goes at positive 4 meters per second. That positive just means it changes direction. It turns around, it goes the other way. And then for 4 seconds, I'm sorry, I can't count. For 4 seconds, it goes at negative 1 meters per second. So it goes pretty slowly, 1 meter per second, and it goes back in that negative direction. Can you find any way to determine the total distance traveled without kind of slogging through those formulas over and over again? And hopefully you can. But if you can't, go ahead and use them. So we have 2 times negative 2 is negative 4. We have 5 times positive 4 is positive 20. And then we have 4 times negative 1 is negative 4. So our total positive displacement in the positive direction during this 11-second event, the object moved 20 meters in a positive direction. It moved 8 meters in a negative direction. So overall, its total displacement is 12 meters. Now here, we have another example. So this is where I'm going to show you a little bit of a shortcut to find, and you're going to be doing the exact same calculation, but it's going to be a little less painful. We're going to see that all I have to do to find out the displacement is to calculate the area under these lines. And this is something that you need to know what I'm talking about when I say area under the line. I mean the area, and it's called the area under the curve, the area between the line and the horizontal axis. So not between the line and infinity, but between the line and the horizontal axis. So we have here, for these first 2 seconds, its area is negative 2. Right? 2 across, negative 1 down, and area is just length times width. So 2 times negative 1 is negative 2. Here we have 2 times negative 3 is negative 6. Here we have an interval of 1, right? This is a length of 1. Times 1 is positive 1. Here we've got 2 times 2 is positive 4. Here's 2 times negative 2 is negative 4. And here's 2 times positive 3 is positive 6. So we can see when we add up all these areas, let me get a pen here. I think yellow should work. Maybe not. Oh, we'll write it. So this is negative 6. This is negative 2. This is positive 1, positive 4, negative 4, positive 6. So when I add this all up, I get a total positive displacement of positive 11. So that's how far it went in the positive direction. And I get a negative of negative 12. So its overall displacement is going to be negative 1. So displacement, if I have a velocity time graph, displacement can be calculated as the area under the curve. And the curve, it doesn't have to be a curve like a curve. It can be a line. That's what we mean. And the area under the curve, remember, is from the line to the horizontal axis. So you're just going to that horizontal axis. So let's look at this. This is a velocity time graph. See if you can answer these before I tell you what the answer is. So you might have to hit pause because I talk fast. During what time interval was the object traveling in a positive direction? Well, we can see that a positive direction would be whenever it's over the horizontal axis, which is here, to 3 seconds, and at 6 seconds it's still positive, and to 8 seconds it's still positive. From 8 to 9 seconds we see it's at rest. So this would be from 0 to 8 seconds. It was traveling in a positive direction. When was it traveling in a negative direction? Anytime its velocity was negative. So that would be from 9 seconds to 15 seconds. During what time interval was it at rest? From 8 to 9 seconds, and that's it. What was the average velocity over the 15 seconds? And this is where you have to not mess up, and you have to practice this a little bit. So to find the velocity, remember average velocity. Is this going to write here if I write it? No, that writes very badly. Let me get a better color. Average velocity is displacement over time. Well, we know how to find displacement. We just found displacement. It's the area under the curve. So let me find the displacement here. This would be 3 times 1 is 3. That's a straight mark, but I'll make it into a plus. This would be 3 across from 3 to 6 and 2 high. So this would be 6. Be 3 times 2 is 6. This would be 2 across and 1 high. So it's plus 2. And there's no other positive displacement. So I can say, well, in the positive direction, the total positive displacement is 11. It should be meters, as this is meters per second. Now let's find the negative. Well, here it's 1 across and it's 2 down, so this is negative 2. Here it's 1 across and it's 3 down, so it's negative 3. Here it's 4 across and 4 down, so it's negative 16. So I'm going to add this up, and I get minus 21. This is my positive displacement and my negative displacement. I have to add these together to get the total displacement, which is what I need to find the average velocity. So this would be, hopefully you can see, negative 10. 11 plus negative 21 is negative 10. Let me get my yellow color back. Negative, it's not writing. I think I got negative, or I don't think I got my pen here. Negative 10 meters, and the time would be 15 seconds. And so I would just do this. I think this would be negative 0.67 meters per second. Oh, it doesn't write over there. That's the problem. Okay, so that should be meters per second. The pen won't write there. So that is its average velocity. And now it's the same question, just with velocity not underlined. During what time interval was it at rest? I think we already answered that. Was it traveling at the same speed? At the same speed. Speed we can look at as the magnitude of velocity. So when was it traveling at the same speed? Well, from 6 to, well, no, it was never traveling at negative 1 down here, but it was traveling at 2 meters per second in a positive direction from 3 to 6 seconds, and it was traveling at 2 meters per second from 9 to 10 seconds. So it had the same speed. It was going in the opposite direction, but 2 meters per second and negative 2 meters per second are the same speed. They're just in opposite directions. What was the average speed over 15 seconds? And we have to, I'm going to try to remember our calculations here. This, I think, was this positive 11 and negative 21? I'm going to say it was. If it wasn't, it's whatever it was. The speed, remember, I don't care about which way it went. I just care about the total amount of ground covered. So I don't care that this was negative and that was positive. I just care about how far this thing went. And to find out how far it went, I just add them together. So speed is distance over time. I don't care about direction. So the total distance here was 32 meters. And the total time was 15 seconds. So it's going to be, the speed's going to be whatever that is when you do it. 2 point whatever meters per second. And that would be the average speed. So I'm just taking the magnitude of the displacement and adding it together and getting speed.